Hey Geometry, welcome back. We're going to do a quick mini lesson on quadratics, so make sure you have something to write with and a pencil. We're going to go ahead and get started. Feel free to pause the video at any point to write down any notes that you need. So what I have drawn on my screen here is a quadratic function. And this special kind of graph has a particular name. This is called a parabola. And you might have heard that word before, but if you haven't, that's okay. Just know that this kind of U-shaped graph is called a parabola, and the equation for a quadratic function looks like this. Y equals x squared. Now, a lot of the time, you'll see this written in different structures because quadratics can have more than one structure. So for geometry, we'll be looking at structure or at the quadratic function written in standard form. So we're going to be looking at something that looks like y equals ax squared plus bx plus c. And in the next example, we'll dissect what all of that means and what to do when we ask specific questions. So sometimes quadratic functions or parabolas can be shifted around the graph. Take this one for example. This red graph has the equation y equals x squared minus 5x plus 6. And sometimes when we graph our parabolas, we want to know where the graph crosses the x-axis. So we want to know what the coordinates of these points are. These are special points. In math, we call these points zeros or x-intercepts or roots. And we use something called the zero product property to help us find what exactly these values are. So let's go ahead and try. So we know that this quadratic has the equation y equals x squared minus 5x plus 6. This is an equation written in standard form. In order to figure out what the coordinates of these points are, we have to factor our standard form equation. So we have to go from standard form to factored form. Factored form tells us exactly what the x-intercepts of our parabola are. So in order to factor, we need to find two pairs of numbers that satisfy two conditions. The first condition is that the pair of numbers has to add to -5. Those same pair of numbers also have to multiply to +6. So they have to add to -5, and that's why I put the little a above the -5, and they have to multiply to 6, to the last term. That's why I put the m. And that just kind of helps me keep things in order in my head. So let's make a list of all the numbers that multiply to +6. Well, I know 1 and 6 multiply to 6, and 2 and 3 multiply to 6. And then I also know that -1 and -6 multiply to -6, as well as -2 and -3. So now that I've listed out all of the numbers that multiply to 6, I need to figure out which pair of numbers adds to -5, because remember, it needs to satisfy both of those conditions. When I look at the first pair, 1 plus 6 gives me 7. So when I add those numbers, it gets me 7. So I know this is not the pair. 2 plus 3 gives me +5. This can't be the pair either because it needs to add to -5. -1 and -6, when I add those together, give me -7. So the pair that fits is -2 and -3. So these two numbers satisfy the condition that when you multiply them together, they give you 6, and when you add them together, they give you -5. Okay, so now that we know which pair of numbers we need to use, we can put it into our factored form. Factored form looks like this: y equals, and then we're going to have two sets of parentheses. At the front of each set, we're going to put an x and an x. And then to figure out what else we put, or to figure out the last numbers that we put in those set of parentheses, we look at the pair of numbers that we chose, -2 and -3. I'm going to go ahead and put those into our parentheses, -2, -3. So now what I have here is that same, is another equation for the same graph. So one is written in standard form, which is right here, and this one is written in factored form. Both of these equations represent the graph that's in red. Okay, but we're not done. Now that we've factored it, we need to use the zero product property. Let me zoom out here just a little bit. So now that we factored, we use the zero product property. And the zero product property states that if I've got two numbers, some numbers A and B, and I multiply them and they equal 0, then either A is 0 or B is 0. One of those numbers has to be 0. So to apply the zero product property to our factored form, what we do is we just take each quantity and we set it equal to 0 and we solve. So we set x minus 2, that first quantity, equal to 0, and I solve for x. To solve for x, I'm just going to add 2 to both sides. So I get x equals 2. And then I also have to set the other quantity equal to 0. So x minus 3 equals 0. And then to solve for x, I'm going to add 3 to both sides, and I get that x equals 3. So that means that x equals 2 and x equals 3. What that means is if I were to plug either of those numbers into either my factored equation or my standard equation, the number that comes out should be 0. These numbers also represent the x-intercepts, aka the zeros, aka the roots of our parabola. So that means then that I've got one x-intercept at 2, 0, and the other x-intercept at 3, 0. In the next video, we'll do some more streamlined practice so that we can get used to factoring and using the zero product property.